Moving on to multiplying polynomials, let's make sure we first understand what a polynomial is. A polynomial is a sum or difference, so plus and minus signs joining together terms, so numbers times variables, that may or may not have different powers of that variable. So some examples. Monomials have one term. So an example of a monomial is something like 3x. It's no plus, no minus, just one combination of number and variable multiplied together. Here's another example, negative 3t to the second. Actually, I used 3 before. Let's use a different number. It doesn't have to be 3's. I just like 3's. How about negative 7t to the second? You can have decimals or fractions, so something like 4.9y to the 8th. All of those are monomials. Binomials, bi like bicycle, means 2. So a binomial is just 2 of these monomials put together with plus signs or minus signs. So some examples. How about 4x minus 7? There you go. It's 2 terms that may involve powers of a variable put together with a plus or a minus sign. What else do we have? How about, let's do one with decimals. 9.6 x to the second plus 5.2x. There we go. That's another binomial. You can even have binomials with fractions. That's okay too. So 2/3 h to the power of 3 minus 4h. There you go. That's another binomial. What matters is there are 2 terms put together with plus or minus. Trinomials, like a tricycle or a tripod, have 3 terms. And typically, we're going to see them looking like this. Something like 2x to the second power minus 5x plus 1. That's a trinomial. 3 terms put together with plus and minus signs. You can, again, use decimals or other variables or other powers. So how about another example of 3.5y to the third plus 11y to the second minus 2/5 y. There you go. 3 terms added together makes it a trinomial. What we want to do together is learn how to take complicated looking expressions like these and multiply them. We already know how to add and subtract them by combining like terms. Let's go about the multiplications. Now, to motivate what we're doing, I want us to think about these 2 multiplications. So when I say multiply without a calculator, I don't know how you were taught, but back in the day, I was taught to multiply this way. You take the 27 and the 36, and then what you do is the 6 times the 7, so that's 42. 6 times 2 is 12. 12 plus 4 is 16. And there you got that. Then I put a 0 and do the same thing with the 3. So 3 times 7 is 21. 3 times 2 is 6 plus 2 is 8. And then I add these up. So 2, 7, 9. I'm now going to take my trusty calculator and see if that went okay. 27 times 36, 972. Looks good. I want to do a similar thing over here. 278 times 5, so that's 40. 5 times 7 is 35, plus 4 is 39. 5 times 2 is 10, plus 3 is 13, so 1,390. Again, I'm going to check. 5 times 278, 1,390. I'm in good shape. Now that we know what the answers are supposed to be, I want to look at this multiplication a different way, because this different way is going to help us multiply the polynomials here in just a moment. I want us to think of 27 as 20 plus 7. So all we're doing is taking that single number and looking at it as 2 parts added together, kind of like a binomial almost. 20 plus 7, so the 10's part and the 1's part. Let's do the same thing with the 36. 30 plus 6. We're going to now take advantage of something called an area. model. Think about this whole big rectangle shape, this whole grid shape. All the area of it added together is length times width, which is 27 times 36, which is 972. What we've done is divide this now into 4 smaller parts. We're going to find the area of each smaller part by doing length times width. So in this case, 20 times 30. So the area of this part, 600. Now you'll notice it's not drawn to scale. 20 is much bigger than 7, but I made the boxes the same size, so we need to use our imaginations a little bit. This next box is 30 tall and 7 wide, so the area, 7 times 30, is 210. Down here, this lower left box is 6 units high and 20 across. 6 times 20, length times width, is 120. And then lastly, 6 high and 7 across, length times width would be 42. I hope I can convince you that the area of the whole big rectangle should be equal to these separate smaller parts added together. So 600 plus 210 plus 120 plus 42, it's going to be 2, 4, 2, 1 is 7, 6, 2, 1 is 9. Oh my goodness, it got us to that same spot. So dividing it into separate parts multiplied together, and then taking those separate smaller parts once they're multiplied, adding them up, got us to the correct result. We're going to take advantage of that in just a moment. You can do the same thing here. Think of a 5 as being this tall height unit here. 278 is just 200 plus 70 plus 8. And now let's multiply. 5 times 200, so this first rectangle has an area of 1,000. This second rectangle has an area of 70 times 5, so 350. And this last rectangle has an area of 5 times 8, so 40. And now the area of the entire big long rectangle is just the sum of these added together. 1,000 plus 350 plus 40 is in fact 1,390. So we multiplied to fill the boxes and then added them up to get the total result. That's how we do these. To multiply 2 polynomials means to do what we just did. Take one of them, put it across the top. 2n plus 3. Notice where I'm putting the plus sign. It's not over the middle, it's with the number on the back. And then down the side, 5n minus 4, so 5n, and then minus 4. Again, notice where I'm putting that minus sign. It's down here with the 4. That way I remember it's really a negative 4 I'm multiplying through. Okay, then, let's see what happens. Multiply to fill the boxes. 5 times 2, n times n. You must remember to put your variables in your boxes here, or else it's going to mess you up later. Remember to put those variables in. 3 times 5 is 15, and this n stays around. Down here then, 2 times negative 4 is negative 8, and this n stays around. And then 3 times negative 4 is negative 12. To finish, take what's in now, these 4 boxes, add them all up. So plus 15 n's. If it's plus a negative, you just write it as a minus. And then like we've done before, if there are like terms, combine them. So our final answer, 10n squareds, 15 minus 8 is positive 7n's with a minus 12 on the back. So there we go. We did our multiplication of polynomials. We drew a little grid, multiply to fill those boxes, and then add them all together once they are filled. So those are the steps to follow. Make your grid, multiply to fill the box. The product is the sum of all those boxes. Make sure you put your like terms together. do a pause here if you haven't already. I want you to try this example on your own, and then unpause when you're ready to check it. I hope that you pause, and you're now just checking your work. So 2 times 3 is 6. B times B is B to the second. 3b times negative 1 is negative 3b. 2b times negative 8 is negative 16b. Negative 8 times negative 1 is positive 8. Put our like terms together, so we got 6b squared. We're adding everything up. So adding a negative is going to be like a minus. So 6b squared minus 3b. One way that students like to do it is they'll often write this top row just like it looks, but then the bottom row, they like to line up the like terms so they remember to add them together. You should feel free to do that. So final answer then, it's going to have 6b squareds. The minus 3b and the minus 16b is minus 19b's, and then the plus 8 just stays a plus 8. Put it all together, and you've got what you need.